Okay, class, today we continue to work on our trig identity problems, our trig proofs, and today we just are going to add 3 more tools to our toolbox. So if we think about the strategies we've been talking about, this is in a little bit different order, but these are the strategies we've been writing down. You're always looking to see if you can substitute Pythagorean identities. You have the option to change things to sine and cosine. If you have a fraction, add them together, or if you have multiple fractions, if you have fractions that you're dividing, you would divide those out. And then you're always looking to factor and cancel if you can. So those are still the same strategies that we're using. Like I said, today we're just going to add another tool to our toolbox to make things more efficient. Now, the good news to remember these tools is there is a cheer that goes with it. So here's how the cheer goes. It's sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Okay, so I want you to repeat that in your head about 15 times right now. So pause the video. I'll do it one more time, but the cheer goes sine, cosine, cosine, sine, cosine, cosine, sine, sine, sine. Okay, and what that cheer does is it allows us to remember the sum and difference identities. There's a sum and difference identity for the sine function, which is that if you have the sine added together, so u plus v, it's equal to the sine of u, cosine of v. If it's plus here, it stays plus, cosine of u times the sine of v. Okay, so you can see that the first angle here goes with the sine first and the cosine second, and then the second angle measure you have here will go with. So again, the way the cheer helps me is that if I have the sum of 2 angles, I remember sine, cosine, cosine, sine. That's how it remembers. Now this sine carries over. Okay, so that's the first one. If this was a minus, then this would be a minus. Okay, so the sign stays the same. Now the second half of the cheer, the cosine, cosine, sine, sine, sine part, that goes for if we have the cosine of u plus v. If we do, it works the same way, where I'd have the cosine of u, but this time I take the cosine of v right away. Okay, so the cosine one works like that. Now the last sign on there is actually sign. That's the one that reminds me to change the sign with cosine. So cosine, since I started with a plus here, I actually switched to the minus. And then it's sine u sine. So because I switched the sign, if instead cosine had started with a minus, it actually switches to a plus. Okay, so I want you to pause the video and get these 2 identities down. Because if we know these, we are allowed to use them quickly and easily to be able to break apart an angle. So again, the cheer, sine, cosine, cosine, sine, cosine, cosine, sine, 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 helps me remember those without just memorizing. Okay, so first we're going to look at the cosine of a sum or difference. We just wrote that down, but this is the way we can use it. Okay, so in the exact value of cosine 75. So this is an example where I don't have a scientific calculator. And 75 is not on the unit circle, so if I don't have a calculator, I can't do that until today. What I'm going to do is I'm going to think of 2 numbers that either add or subtract to get to 75 that are on the unit circle. So right away I think of 45 plus 30. So I'm going to rewrite this as the cosine of 45 degrees plus 30 degrees. And now because it's cosine, I'm going to use the cosine part of the cheer. And that was the cosine, cosine, sine, sine, sine. A lot of times what I'll do is I'll just write that down because I'm just thinking the cheer in my head. I say, okay, cosine, cosine, sine, sine. And then when I say the third sign, I remember that it changes from plus to a minus. And then I just go through and I go every other with my angles. So I go 45, 30, 45, 45, 30. And now I can simplify because I know what those are on the unit circle. So cosine of 45 degrees I know is root 2 over 2. Cosine of 30 degrees is root 3 over 2. Minus sine of 45 is also root 2 over 2. And sine of 30 is 1/2. I multiply my fraction straight across. I get root 6 over 4 minus root 2 over 4. And because they have a common denominator, I can simplify. I get root 6 minus root 2 all over 4. And yes, you do leave your answer like that. It's ugly, but we just leave it like that. Okay, so that's one example of how we can use the cosine of a sum or difference. Okay, we already wrote that down. So I did practice number 8. I want you to pause the video and try that and then come back and check it. Okay, so you should have recognized that it's a cosine of a difference. So I'm going to do, I'll write it over here, cosine, cosine, sine, sine, and then don't forget to change your sign. It's a minus here, so it's a plus. Pi over 4, pi over 6, pi over 4, pi over 6. So I just alternate. And then I know that cosine of pi over 4 is root 2 over 2. Cosine of pi over 6 is plus sine of pi over 4 is root 2 over 2. Sine of pi over 6 is 1/2. So those are the same numbers, but it's a plus instead. Multiply across. Again, I can multiply two radicals as long as they're the same. So root 6 over 4 plus root 2 over 4. My final answer is root 6 plus root 2 all over 4. It's almost identical to the last one, except it was a plus. All right, so we can also use the sine one. Again, we just have to remember the sign here. So sometimes you're given the expanded form, and you can write it as a sine or cosine of an angle, so as a single thing. So when I'm given something like this, I look and see what I have, and as soon as I see sine and cosines together, I know it's the sine chair, but it's the sine, cosine, cosine, sine. You'll notice that these are switched, but that's okay. So I know it's the sine. Sine, my angles are pi over 3, pi over 4, so I put those inside. And then sine is the one where if it's plus there, it stays as a plus. Okay, so I can rewrite it like that, but to get it as a single angle, I need to be able to add together pi over 3 plus pi over 4. Common denominator would be 12. So my 4 pi plus 3 pi over 12, I get 7 pi over 12. I get the sine of 7 pi over my answer. So this is the other way we can see these problems. Okay. You'll see on this one that the order of the second one switched, but it's important that the angles also switch. So I could have switched that to plus cosine pi over 3 sine pi over 4, and that would have matched it exactly. The reason I say that is we're going to just look at an example from the book and talk through it. So when we look at this next example, it says write as a single sine or cosine of an angle. And right away I see sine, sine, cosine, cosine. I see the sines and cosines are together. So I recognize that it's going to be the cosine sum or difference. So it's going to be cosine, cosine, sine, sine, sine. Problem is they're backwards. So I somehow need to get this one. By next step, I just moved it, but I have to bring that negative with it. So I have negative cosine x, cosine 2x plus sine x, sine 2x. Problem is I can't use it here as long as this is here. So I would have to factor that out. So once I factor out the negative 1, then you can see it follows cosine, cosine, sine, sine. Since it's a minus here, it becomes a plus. Okay, so this is an example where you'd end up with a negative cosine of 3x. Okay, that's just another unique thing. I want you to take a minute now and try guided practice number 9. So once again, pause it and then come back and check it. Again, what I saw when I did this is sine, cosine, so I know it's the law of sines. It's a plus there, so it's 5 pi over 12 plus pi over 3. I quickly do my common denominator. I know it needs to be 12, so it gives me 4 pi over 12. So ultimately, 9 pi over 12. That reduces to 3 pi over 4. So my answer is sine of 3 pi over 4. So we do have to continue to be good at working with fractions. Okay, another example of how this is used. Find the sine of 11. Again, I have to think of two things on the unit circle that add up to 11 pi over 12, or subtract pi over 12, or 11 pi over 12. Now, the harder thing about this one is that I don't know any over 12s on the unit circle, but I do know over 3s and over 4s. So common denominator 3 and 4. Okay. So when I think about it, I know that like 8 pi over 12 plus 3 pi over 12 gets me to 11 pi over 12. And so I can reduce that. These are both divisible by 4. That's 2 pi over 3, which is a unit circle measure, plus pi over 4, because those are both by 3. So you'll see that sometimes you have to work a little harder, especially when it's in radians. I have sine of 2 pi over 3 plus pi over 4. So now that I have the sign of a sum, I know I can use the sine, cosine, cosine, sine part of my cheer. So again, I always do the cheer in my head. I'm like sine, cosine, cosine, sine. I fill those in. Sine is the one where the plus stays, so I put a plus between, and then I alternate my angles. 2 pi over 3, pi over 4, 2 pi over 3, pi over 4. And again, I need to be good at my unit circle. I know that the sine of 2 pi over 3 is root 3 over 2, because sine is positive in quadrant 2. Cosine of pi over 4 is root 2 over 2. Cosine of 2 pi over 3 is negative 1/2, because cosine is negative in that quadrant, and sine of pi over 4 is root 2 over 2. Multiply across, I get root 6 over 4. I have a negative, so I have minus root 2 over 4. Once again, I get root 6 minus root 2 over 4. So you can see that you're going to end up with similar answers because you're numbers, which really only deal with root 3 over 2's, 1/2, and root 2 over 2's. All right, go ahead and try guided practice number 10. Again, find the exact value, so find a way to break it apart. So guided practice number 10, what I did negative 5 pi over 12 minus 8 pi over 12. Again, there's other options that could get you there, which gives me pi over 4 minus 2 pi over 3. So I chose to use this as my option. I'm going to go up here, and so I did sine of pi over 4 minus 2 pi over 3. So I have sine, cosine, sine. So then I set up my chair because it's minus. I put my minus, and then I alternate my angles. Pi over 4, 2 pi over 3, 4, 2 pi over 3. Again, I know that pi over 4 is 2. We just talked about cosine 2 pi over 3 minus cosine pi over 4 is root 2 over 2, and sine 2 pi over 3 is root 2. In this example, I get negative root 2 over 4 minus root 6 over 4, which is negative root 2 minus root 6 over 4. And that would be my final. One quick proof, just to kind of connect this to what we're doing. We can also use these in proofs, and you will do that from time to time. So if I see the cosine of x plus 3 pi over 2, and I have to get it to be the sine of x, because I notice that there's a sum of two angles, I try my so I use cosine, cosine, sine, sine, and I know the third sign tells me to switch it from a plus to a minus. Alternate my angles, 3 pi over 2, x 3 pi over 2. So then I have cosine of x on my unit circle. Cosine of 3 pi over 2 is 0 minus sine of x, sine of 3 pi over 2 is negative 1. So anything times 0 is 0. I have negative sine x times negative 1, which a negative times a negative gives me positive sine of x, which is my answer. Okay, last but not least, I want you to try guided practice number 11. So pause it, try it, and check it. So what I did for this one is I used the sum of a difference here. So sine, cosine, cosine, sine, and I know that it's minus. So it's a b all over sine a sine b. And in this one, you actually had to break it apart as two fractions, and I recognized to do that because of the two pieces here. So I have sine a cosine b over sine a cosine b minus cosine a sine b over sine a sine b. This is all the same, so that divides to be a 1 minus. I know that cosine over sine, they're both a's, so that is the same as cotangent of a and sine b. Oh, sorry, this was supposed to be cosine over cosine b. This would give me tangent of b. So you can see that was trickier, but